A particle moves in the xy plane so that its position at time t is r is cos t cos 2t. Find the Cartesian equation of the path. Well, we can see that x will be equal to cos t and that y will be cos 2t. Now, one trigonometric identity we know for this is 2 cos squared t take away 1, and cos t is x, so we can say that that's 2x squared minus 1. We want an expression for the velocity vector of the particle, and then we want to find the exact speed when t is pi by 4. So we'll get v by differentiating. So differentiate cos and we get negative sine. We need to use the chain rule here and we'll get negative 2 sine 2t. So v of pi by 4 would be, so that's going to be sine pi by 4, which is root 2 over 2, so negative root 2 over 2. And 2 lots of pi by 4 is pi by 2. Sine of pi by 2 is 1, so that's negative 2. So the modulus of that would be the speed. So that's going to be the square root. If we square this, we get 2 over 4, or a half. Add 4, so that's the square root of 9 over 2, which is root 9, which is 3 over root 2, and 3 root 2 over 2 if we multiply top and bottom by root 2 to rationalize the denominator. Show that the velocity and acceleration are perpendicular to each other the first time that the particle passes through the point 0, 1. So if we think about 0, 1, that means we need that cos t is equal to 0 and cos 2t is equal to negative 1. Well, if we have t equal to pi by 2, that would do the trick, because cos of pi by 2 is 0 and cos of pi is equal to negative 1. This must be the first time, because when t is 0 we're not at the point 0, negative 1. So if we think about v of pi by 2 coming down to here, that's going to be negative 1 and 0. Now let's think about a. So differentiating this would give me negative cos t, and differentiating this would give me negative 4 cos 2t. So a of pi by 2, we know cos of pi by 2 is 0, and cos of pi is negative 1, so this will be positive 4. And if we do negative 1, 0, and we dot that with 0, 4, we get 0.